We tend to think of science as this big book of answers, right? But honestly, the really exciting part, it's the questions, the huge mind-bending ones we haven't cracked yet. And today, we're going to tackle two of the absolute biggest.
All right, let's just jump right in. Look at this number, 4.9%. Any guesses what that could be? Go on, take a shot. I'll give you a hint. It's a number that basically defines, well, everything, our entire reality. And yet, look how tiny it is.
So that 4.9%? Yeah, that's everything we can see and touch. The device you're watching this on, the coffee in your cup, the stars, you, me, all of it. It's just a tiny sliver of the whole pie. The other 95%, well, that's made of stuff we call dark matter and dark energy. And honestly, we have almost no idea what they are. So that's our first giant mystery, the universe out there. But the second one, that's the universe right in here.
Okay, let's start with that massive, staggering 95%. I mean, think about that. This is the invisible, untouchable stuff that's secretly running the whole show, dictating how our entire universe works.
Now, when we say dark matter or dark energy, it can sound kind of spooky, right? But it's not evil or anything. It's dark in the sense of being in the dark about it. It just means it's a complete mystery. We can't see it. It doesn't give off light. It doesn't seem to interact with, well, anything. So the big question is, how in the world do we know it even exists?
Well, we can't see it, but we can definitely see what it does. See, way back, astronomers like the famous Edwin Hubble noticed something really weird. All the distant galaxies were flying away from us. But they weren't just moving away, they were accelerating, speeding up. Something has its foot on the gas, pushing everything apart. It's like a cosmic anti-gravity force. We gave it a name, dark energy. But what is it? No clue. We just see the chaos it's causing.
And it doesn't stop there. Get this. When we look at galaxies like our own Milky Way, the math is just wrong. Based on all the stars and gas we can actually see, the stars on the outer edges are spinning so ridiculously fast they should just get flung off into space, like kids flying off a merry-go-round that's going too fast. But they're not. They're sticking together. Which means there has to be some kind of invisible stuff there, some extra mass providing the gravity to hold it all together, like a cosmic glue. And that is what we call dark matter.
So, here's the kicker. Dark matter isn't just some cosmic band-aid holding things together now. It was absolutely essential from day one. Physicist Risa Weschler puts it perfectly. Without that extra gravitational pull from dark matter in the very beginning, the regular matter, the stuff we're made of, would have just been this thin soup. It would never have clumped together to form the very first stars and galaxies. No dark matter, no us.
Okay, so what on earth could this stuff actually be? Well, the leading candidate for dark matter is some kind of brand new particle we've never seen before. The main suspect has a great name, a WIMP. It stands for Weakly Interacting Massive Particle. And that name says it all, right? It's a heavy particle that barely interacts with anything. So, how do you even begin to find something that's practically a ghost?
Well, you have to get pretty extreme. Scientists have literally gone deep underground, like a mile deep in an old gold mine, to build these incredible detectors. They're trying to escape all the cosmic noise at the surface. They fill these enormous vats with super pure liquid xenon, and then they just wait. Seriously. They're waiting for that 1 in a billion chance that a WIMP, a ghost particle from space, flies through all that rock, straight into their tank, and just happens to nudge a single xenon atom, creating a teeny tiny flash of light. It has to be one of the most patient searches in all of science.
All right, so that's the huge mystery out there in the cosmos. But for our second mystery, we're going to pull a complete 180. We're going from the mind-boggling scale of the universe to the most intimate, familiar thing we know, our own consciousness. The mystery of what it feels like to be me.
Let me ask you something really simple. Think about the color red. When you look at a red apple, you have an experience of red, right? And so do I. But here's the question. Is your internal feeling of redness the same as my internal feeling of redness? Is there any way we could ever possibly know for sure? This private, personal, subjective quality of an experience, that's what philosophers call qualia. And that is the core of this whole puzzle.
This whole thing is what the philosopher David Chalmers famously called the hard problem of consciousness. See, science is getting really, really good at what we could call the easy problems, explaining how neurons fire, how the brain processes light waves, and basically what the brain does. But the hard problem is, Why does all that electrical and chemical stuff feel like anything? Why isn't it all just happening in the dark, without an inner experience? Why is there a what it's like to be you?
Another philosopher, Thomas Nagel, put this brilliantly. He asked, what is it like to be a bat? Think about it. We could, in theory, learn every single physical fact about a bat's brain. We could know exactly how its sonar works, how it processes those sound waves to create a map of its surroundings. But would we ever really know what it feels like to see the world with sound? Almost certainly not. That experience belongs to the bat and the bat alone.
There's this fantastic thought experiment that really drives this point home. It's probably the most famous one in all of philosophy of mind. It's called Mary's Room, and it shows the massive difference between knowing about something and actually experiencing it.
Okay, so picture this. There's a scientist named Mary, and she's a genius. But she's lived her entire life in a room that is completely black and white. She sees the world through a black and white monitor. But here's the twist. She has become the world's leading expert on color vision. She's read every book. She knows every single physical fact there is to know about what happens in our eyes and brains when we see the color red, for example.
Then one day, someone opens the door. Mary steps out into the world, and for the very first time, she sees a real, vibrant red rose. She has the actual experience of seeing red.
So here is the million-dollar question. Does Mary learn something new? If the answer is yes, and it feels like it has to be yes, then that means something huge. It means that all her knowledge, every physical fact in the universe about color, was incomplete. It means that the feeling of seeing red, the experience itself, is a whole new piece of information. And that is the hard problem of consciousness in a nutshell.
So there you have it, two absolutely enormous mysteries. One has us staring out into the cosmos at the very fabric of reality. The other has us staring inward at the very nature of our own minds.
And what's so cool is how similar they are, in a way, right? For the cosmos, we've got 95% of the universe that's physically out there, but it's basically invisible and untouchable. Then, with consciousness, we have this internal experience that is the most real thing to us, but it's totally private and unobservable to anyone else. They both represent a kind of wall that our current science just can't seem to get past.
So why should we even care about any of this? Well, because solving them would change everything. Figuring out what that missing 95% of the universe is would completely rewrite physics. And finally understanding how a lump of cells in our heads creates this rich inner world that would totally transform biology, psychology, our entire understanding of what it means to be human.
And that kind of leaves us with one final big thought. Just think about it. We are beings made of that tiny 4.9%, using our minds, which are themselves a profound mystery, to try and understand the other 95% of reality. So, if we ever actually solve these two massive puzzles, would it change what it even means to be human? Would we even be the same creatures who started asking these questions in the first place? Something to think about. Thanks for joining me.